Yes, today our topic is to learn about validity regions for the binomial expansion and to sort out our advanced questions in this binomial expansion. So this is today's the last part of this topic. So anyway, if you happen to see any kind of a binomial expansion, so they might give you a question somewhere like this. Right, okay. We'll go to one question. Then with that, we can just try to work out. I'll just go to page number something. Yeah, right. Okay, here. They might ask a question like this kind of situations I'm discussing about, that is called the valid region for a binomial expansion. That is why we are mainly focusing this one. Right. Okay. Let's see. Initially, we'll come up with the question and try to understand how do you verify these things. It's mentioned. They might give you a question like this: 2 plus x over 1 plus 5x. Find the x squared term of the sequence, the expansion of fx. State the range of value for x where the expansion is valid. Right. Okay. Then binomial expansion. That means, like if the binomial expansion, we get it for 1 plus ax to the power a. If we expand this one, the valid region would be, means you cannot substitute the values away from these ones. Only thing is that for this kind of it, you can say the modulus of ax should be less than or equal less than 1. That is a region where this function become valid. That means you can say you can take this a out because it's just like when you get the modulus, it's just like this 1. Therefore, x become modulus of x become less than 1 over a. That is a fact we have to understand. Right? Okay. Let's come up with this kind of situation. For example, if you happen to see 1 plus 2x, the square root of it. We want to expand this bracket. If you want to expand it, you can say this is 1 plus 2x to the power half. Right. Let's go ahead with this question. If you do this expansion, you can say this is 1 plus n is half x, 2x over factorial 1 plus n minus 1. So this is 2x whole thing squared divided by factorial 2. Like that, if you write another term, 1 over 2 and minus 1 over 2, then this is turned up to 2x to the power 3 over factorial 3. Right? Okay. Plus it goes on. It's an infinite series. So if you simplify, this is turned up to 1 plus x. Then this is turned up to 2 and 1 to get cancels with this. Then another 2 comes with this. It's turned up to minus 2x squared. This half get cancels with the, 1 over 2 into 1 over 2. Just we will just work out with this. So if you want to work out this one, what you can understand is just 1 second. Yeah, 0.5 half into yeah half into minus half. Then the next one is 2 squared is 4. This answer divided by 2. Answer is minus half. Yeah, so this is yeah, so this is not 2x squared, it should be half x squared, half x squared. Half x squared, if you work out over here, this is half into minus half into minus, there's another part is missing over here. So n minus 1, there's another term should be come over here, that is n minus 2, that is minus 3 over 2, that should be come up with the count. Minus 1.5 into 2 cube is 8, divided by factorial 3 is 6. That is half. So this is done up to half x cube, like that it goes on to the. Then they can ask you is a valid region for this. Valid region for this. Valid region become modulus of 2x should be less than 1. That is, modulus of x is less than 1 over 2. So what do you mean by modulus of x is less than 1 over 2 means x is in between plus half to minus half. This would be the valid region for this. That is what you mean by the valid region. Then what we need to understand is, what do you mean by what is the use of learning this valid region? That is a fact where we have to understand. So there are a lot of reasons to learning about this valid region, but for certain cases, if they want to find out this kind of situation, in another part of a question, they can ask use above expansion to find an approximation value for 0.98 square root of it. Right. For this case, you can say square root of 0.98, it's equals to square root of 1 plus 2x. So same concept where we can use it. That means you can say 0.98 equals to 1 plus 2x. Therefore, x become 1 minus 0.98 divided by 2. That is turn up to, divided by minus 2. Then it is turn up into minus 0.01. That means if you want, now you can see this minus 0.01 is within this range. Therefore, to get this approximated answer for 0.98, we can substitute this minus 0.01 into this function. So you can say 0.98, the square root is approximately equals to 1 plus minus 0.01 minus 1 over 2 minus 0.01 squared plus 1 over 2 minus 0.01 cube. Like that you can get this answer. Let's substitute and you can obtain this answer. That is 1 minus 0.01 minus half into cube. So you get the answer 0.9899. 0.98999495, right? Then let's see actually what is the answer for 0.9, the square root of 0.9, whether it's kind of a similar answer to this. Yes, the actual answer is 0.989949 366. So it's approximately this value is kind of close, so it doesn't make impact on that. That is the applications of learning about this valid region for binomial expansion. Let's go ahead with one little bit of a extended solution for this. Then how to find this valid region for this kind of situation, right? Yeah, I'll come up with this question today. They have given us, when you're talking about this question, I am just going to discuss about, that is in our this book examples. Yes, yeah, we'll go ahead with this question today. X plus 4 minus 5x over 1 plus x into 2 minus x as a partial fraction. Can you show that the cubic approximation for this? What do you mean by cubic approximation? Means you are right up to x to the power 3. For this much is this clear to show that state the range of the value for x for which the expansion is valid with it, right? So initially what you can get here is, we can do it. The question is 4 minus 5x over 1 plus x, 2 minus x. 1 plus x, 2 minus x. So initially, so you while keeping this format, it's like if you just apply by what you call that binomial expansion, just like this, 4 minus 5x times of 1 plus x to the power minus 1, 2 minus x to the power minus 1. Then we need to write, if you just apply binomial expansion for this situation, they expect you to write up to x to the power 3 put there. So here there's nothing to expand because it's already there. So there are two terms. If you do up to power 3, there should be 4 terms. If you do up to here, there should be 4 terms. So you have to expand of 32. You have to do expansion for 32 terms and to simplify into cubic expression. This is quite hard for us to do. That is why we need to go ahead with the partial fractions to do this kind of situation, the question for them. Right. Okay. Let's see how to do this kind of question. Right. So just like this. Initial, I'll get into partial fractions. 4 minus 5x 1 plus x into 2 minus x. Therefore, you can say this is equals to a over 1 plus x plus, I think you know how to do this, expand these ones. I'm not going to explain it again. If you have any doubts, just go ahead with the partial fractions, the topic, the videos, and you just watch it. And if you feel like that one also hard, you just contact me. 2 minus x plus b times of 1 plus x. So with that you can say if you get x equals to 2, this get cancels. 4 minus 10 is 6 minus 6 is equals to 3b. Therefore b turn up into minus 2. So if you substitute x equals to minus 1, this get cancels. So minus 5 is 9. 9 equals to 2 minus 2 plus is 3a. Then a become 3, right? Okay, like that you can get this answer. A equals to 3 and b equals to b equals to minus 2. So so this expansion turn up into 4 minus 5x over 1 plus x into 2 minus x turns into a expression like this, 3 over 1 plus x minus 2 over 2 minus x. Right. Now I'm going to expand this. Then you can say this expression as this format. 3 times of 1 plus x minus 2 times of 2 minus x. That is a way of getting this. Now you have to, sorry, to the power minus 1. Then you have to do this expansion. For the initial, I just get the expansion of the first part of it. 1 plus x to the power minus 1. So you can say this is 1 plus n x over factorial 1. They need to find out to x to the power 3. n minus 1 x squared over factorial 2. Right. Then n minus 1 n minus 2 3 over factorial 3. Right. So if you operate this, you will get the answer 1 minus x plus x squared minus x cubed. Right. That's the answer for that. Right. Okay, we'll keep that answer for a while. Then we need to get the expansion for 2 minus x to the power half. So power minus 1, right? Okay. Now we have a doubt over here because while keeping this term as 2, you cannot do it. Anyway, you have to convert into 1. There with that, I'll take 2 out. So it's turn up to 1 minus half x whole thing to the power minus 1. So this is turn up to 2 to the power minus 1 times of 1 minus half x to the power minus 1. 2 to the power minus 1 is 1 over 2. 1 minus half x to the power minus 1, right? Okay. Then we'll go ahead with this. Half, so you can do this expansion. 1 plus n x minus 1 over 2x nx factorial 1. So if you want, you just write, ignore this because it's factorial 1 is 1 anyway. It's n minus 1 minus 1 over 2x whole thing to the power 2 over factorial 2. The next one is n minus 1, n minus 2, it's 1 over 2x to the power 3 over factorial 3. Right, okay, then we are going to expand this to the right. If you come across with this, it's turn up into half 1, so if you operate this is turn up to 1 over 2x. 1 over 2x, the next fact is minus 1 into minus 2, just minus 1 minus 1 into minus 2 into 1 over minus 1 over 2 squared is 1 over 4. 1 over 4. This answer has to be divided by factorial 2. That answer is 1 over 4. So this is turned up to plus 1 over 4x. 4x squared, right? Then if you operate this, this is turned up into yes, plus 1 over 8. Plus 1 over 8 x to the power 3. Right? Like that it goes to the infinity. So if you expand with half, you can say this is equals to 1 over 2 plus 1 over 4x plus 1 over 8 x squared plus 1 over 16 x to the power 3. That is the answer for that. Then you can write this above expansion, that is 3 times of the first expansion minus 2 times of the next expansion. So you can say then the final answer is this part of it, 3 into 1 plus x to the power minus 1 minus 2 times of 2 minus x to the power minus 1. This expansion you can write 3 times of the first part of it, 1 minus x plus x squared minus x cube minus 2 times of this bit. 1 over 2 plus 1 over 4x plus 1 over 8x squared plus 1 over 16 x to the power 3 goes on like this. Then if you do this, it's turn up to 3 minus 3x plus 3x squared minus 3x cubed. Then I'll just expand it and write it below with the same order. Minus 2 into half is minus 1. Minus 2 into 1 over 4 is minus 1 over 2x. Minus 2 into 1 over 8 is minus 1 over 4x squared. Minus 2 into this is minus 1 over 8 x to the power 3. Then you can do this expansion. If you expand it, you will realize it. 1 minus 3 minus 1 is 2. Minus 3 minus half is minus 7 over 2x. 3 minus 1 over 4. It's, yeah. Yeah. Total, here this is 3 minus 1 over 4. It's turned up to plus 11 over 4. X squared minus 3 minus 1 over 8 is minus 25 over 8 x to the power 3. This is the final expansion for this. Yeah, right. Then our doubt is to find the valid region. How to find the valid region for this? I'll just a little bit minimize to see the entire question at once for you all. This is the complete answer for this for your references. Right. Then if you come up with this, sorry, the valid regions, we'll go with valid regions. You know that the first one is 1 plus x. 1 plus x to the power minus 1. For this, the valid region become modulus of x is less than 1. That means x is in between plus 1 to minus 1. Okay. But the second one is, that is, if you do to break up in this situation, you have to check with this, but not with this, you have to check with this 1 minus half x. So you can say 2 minus x to the power minus 1 minus half modulus of x is less than 1. So modulus of minus half also plus half. Therefore, it's turn up to, if you just do this, you can say modulus of x is less than 2. If you cross multiply with this, that is x is in between plus 2 to minus 2. Right. Okay. Now we need to find what is the common region for this. So initially we can on a number line 0, 1, minus 1, 2, minus 2, so on goes on. So the first one is in between here to here. Not this point, it's not there, sorry, just it is that part of it. Minus 1 to plus 1, and the second one is from minus 2 to plus 2. So Actually, there's another mistake I made it. Metana, you cannot just draw the colored dot. Why we cannot draw the colored dot? Because equal mark is not there anymore. So it's just a, what do you call that? Equality is not there. So you can just put to draw dots like this. And 2 is like this way around. Then the common region is where to where. So you can say the common region falls over here to here. That's a common region for both. Therefore, the valid region become x is in between +1 to -1. That would be the valid region for this kind of a question. That is a way of doing this kind of situation. Right. Okay. Hope you can understand how we get this answer. Right. Uh, yes. Then let's go to this question today. Or you can do these questions. Those are not that hard things. I think question number 5 we did previous video, right? Then just there is one. We'll see whether the substitution and this one. Yeah. So when you come up with this kind of a question today, that is what they have given is fx equals to 2x squared plus 5x plus 11, where 1 over 2x squared plus x plus 1 can be expressed in form of this. Find the value for a and b, c, a, b, c, and c. That means they are referring with the partial fractions. Hence, otherwise, find the expansion of series in the ascending power of x up and including x to the power 2. So we do the reference up to x to the power 2. Find the percentage error made by using the series of the expansion of the part B to estimate the value for f 0.05. Give you answer to two significant figures. Let's go ahead with this answer. Right. Okay. Then I will start with a new page. They have given us the question this way. Right. The question is 2x squared plus 5x plus 11. 2x squared plus 5x plus 11 divided by 2x minus 1. 2x minus 1 squared into x plus 1. Yeah, x plus 1. Yeah, x plus 1, right? So initially what you need to do is, when you before turn up the partial fraction, see whether the power of the numerator is equal or greater than the power of the denominator, but it's not that, because the power of the denominator is 3, but it's 2, so no need of working on it. Rather than that, as we learned in the last video, we have to use a long division and to make them into a form of power of the numerator become less than the power of the denominator. So initially we can write the partial fractions with it. Here it's a power equation, so you can say this is a over x plus 1 plus b over 2x minus 1 plus c over 2x minus 1 squared. If you happen to see a powers, you write all the minimal orders at the denominator, right? Then you can say this is 2x squared plus 5x plus 1 is equals to, then you will take the LCM. But the LCM is the same thing. That will turn up to a times of 2x minus 1 squared plus b times of 2x minus 1 times of x plus 1 plus c times of x plus 1. That is a way of getting this expansion for this, right? Okay. Initially, if I replace x equals to 1 over 2, you can obtain the answer for C, right? Because if you put 1 over 2, this term gets 0, this term gets 0. So therefore, these two terms won't be there in the expression. So 2 into, so we'll get the right hand side. 2 into half squared is half. Half plus 5 into half. 5 into half plus 1. So this is turned up to 4. So it's turned up to, this is turned up to 4. is equals to all these terms get cancels. So this is turned up to 3 over 2c. So with that c become 8 over 3, right? That is a substitution. If you put half into this one, half into this is like, yeah, that's it, right? Then the next value we can substitute is, we can substitute x equals to minus 1. If you substitute x equals to minus 1, you can see these two terms get cancels. If you put minus 1 over here, that is turned up to 2, minus 5 plus 1, that's turned up to minus 2, is equals to these two terms get cancels. If I put minus 1, minus 3, it's 9, 9a. Therefore, a become minus 2 over 9, right? Then the next value we can substitute is, we can just put random value x equals to 0. If you put here, it's 1, and this is turned up to, if I put 0 here, this is turned up to a, and this is turned up to b plus c. So we know the answers for a value we know, minus 9 over 2. B value we don't know, b. C value we know, 8 over 3. So with that you can get the answer for b with it. B is equals to 1 plus 9 over 2 minus 8
So
over, yeah. Any doubt with it? Just see with it. No, correct. Where are the other?
8 just 2 over 9, right?
A is, just 1 second.
Minus 2 over 9 or minus 9 over 2?
Mine's 2 over 9. Sorry, 2 over 9. This is wrong. Eh? This is turned up to minus 2 over 9. I just made a mistake. Sorry. Then you can say 1 plus 2 over 9 minus 8 over 3. Minus 8 over 3. Minus 13 over 9. Just turn up to minus 13 over 9. Right. Okay. Then what you need to do is, then this expansion turns in this format with it. So here, this is turned up to a. A is minus 2 over 9 x plus 1 to the power minus 1. B is minus 13 over 9, 2x minus 1 to the power minus 1 plus c. C is 8 over 3, 2x minus 1 to the power minus 2. Right. Then our objective is to expand these brackets. So I'll just quickly do it. So here, this case is not a problem. Over here, you can say x plus 1 to the power minus 1, you can say 1 plus n, n is minus 1, x is x of factorial 1, n minus 1, x squared of factorial 2, then n minus 1, n minus 2, this is 3 of factorial 3. So with that, if you do this expansion, it's turn up to 1 minus x plus x squared minus x cubed, right? Then the next part is the other part is important. That is, this turn up into minus 1 plus 2x to the power minus 1. Therefore, you have to make it 1. So therefore, I need to take minus 1 out. Minus 1, this is turned up to 1 minus 2x to the power whole thing to the power minus 1. So this is turned up to minus 1 to the power minus 1 times of 1 minus 2x to the power minus 1. Then this is turned up into minus 1 to the power minus 1, also minus 1. Then if you do this expansion, 1 plus n, x, n minus 1 square divided by factorial 2, then n minus 1, n minus 2, 3 over, sorry, here they need to work out only x to the power 2. So don't need to write in this, because they need the expression in the question itself. They mention do the expansion up to x to the power 2. Sorry, yes, power 2 only. So that is this question you're discussing about. Sorry, this one, x to the power 2. So not writing up to x to the power 2 is enough. Yeah, so you can do this expansion. So this turn up to minus 1. This is plus 2x, and this is turn up to they cancel, it's turn up to to get cancels. It's turned up to 4x squared. 4x squared, right? Then the last part is we need to work out with this bit. Minus 1 plus 2x to the power minus 2. So this is turned up to, so initially you have to take minus 1 out, minus 1 to the power minus 1. Then this turn up to 1 plus 2x, 1 minus 2x, sorry. 1 minus 2x, whole thing to the power minus 2. So this is turned up to minus 1 to the power minus 2 is plus 1 pute. Into this is 1 minus 2x to the power minus 2. So you have to do this expansion. So it's turned up into 1 plus n into minus 2x or factorial 1. Then n minus 1 minus 2x whole thing square divided by factorial 2. Okay, that's what you need to get it. So from here you get the answer 1 plus 4x. Then this is 2 and 2 get cancels. Minus, anyway, it's plus value. It's plus value. Minus, or all the you simplify, minus squared is plus. So it's 4 into 3 is 12. 12x squared, right? Then we can write this expansion over here. So if you just use it, you can say this is the total expansion is equals to minus 2 over 9, the first expansion, this bit, 1 minus x plus x squared. Then the next one is minus 13 over 9, the next expansion, minus 1 plus 2x plus 4x squared. The last one is plus 8 over 3, 1 plus 4x plus 12x squared. Right. Then, so after that, what you need to do is when you simplify, you can obtain this answer. I think you can get that answer. The next part, what they're referring is substitute f equals to c. Sorry, the question given here is it just like this. I'll quickly do it. Find the percentage error made using the x series of the expansion b of f 0.05. Right, for this part of it. Then, so what you need to do is put to get the exact value. So you can put f 0.05 to the right hand side. Right hand side means you have to substitute over here, this part of it, make over this part of it, and yeah, and again you have to substitute 0.05 into this expansion. So initially, if you just put this is the absolute value. Absolute value is if you substitute 0.05 into this function, just the right function. Sorry, the left, the function is the right hand side. Put 0.05 squared plus 5 into 0.05 plus 11 divided by 2 times of 0.05 minus 1 squared, then 0.05 plus 1, then you can get the absolute value. This is the absolute value. Then the approximated value is, so you can just get, you can substitute into this. So you can just say, after simplified version, you can get it 0.9, 1 minus 0.05 plus 0.05 squared minus 13 over 9, because it's a simplified version, nothing to worry, you can get them straightforward. 2 times of 0.05 plus 4 times of 0.05 squared plus 8 over 3, like the same thing you can substitute with it. Then the absolute value. Then how to find the percentage error? They ask about find the percentage error. Percentage error is this way. Can you get it with it? Percentage error is absolute value minus approximated value divided by the absolute value into 100. Then after that, you can put a percentage over here. With that, you can get the final answer for this. Is that clear?
Yes.
Right. Like that, then you can do these kind of questions, right? Then